What if you could work with some of the world's most innovative companies, all from the comfort of a remote workplace? Andela has matched thousands of technologists across the globe to their next career adventure. We're empowering new talent worldwide, from Sao Paulo to Egypt and Lagos to Warsaw. Now, the future of work is yours to create. Anytime, anywhere, the world is at your fingertips. This is Andela.
Hi there, my name is Kazuki. I've been coding Go for nearly 4 years now. Today, I'd like to talk about how Go works to bind a port and listen for the port when starting an HTTP server on a random available port. In this session, I will deep dive into the inside of standard libraries net and syscall. I hope you'll find it helps you understand HTTP and TCP programming in Go. First, let me introduce myself. I am a backend engineer at Otify. Otify is a no-code AI-powered software testing automation platform. You can find me on Twitter. I've been publishing blogs and presentation materials on this Twitter account. Please follow me and check it out. Let me explain Otify just a little more. First, Otify allows anyone to automate testing with a no-code solution. Otify records the user's action on the service they want to test and converts it into a test scenario. Second, AI updates test scenarios accordingly as the application changes. It dramatically reduces maintenance costs for the users. We have two services, Otify for web and Otify for mobile. We're taking demo requests from you. Okay, let's get down to the main topic. Let's say you need to implement an HTTP server on a random available port. We usually specify a port such as 18 or 443 when setting up an HTTP server or HTTPS server. In this case, the code does not specify a port where the server runs. An HTTP server binds an available port dynamically and listens to it. How would you implement this? The answer is straightforward. Here is a sample code with a minimum number of lines. Look at the second argument of the net.Listen function in the second line. I passed 0 to the second argument. This way, the port assigned changes each time the server runs, as you see in this slide. The Go document of the net package describes the behavior. If the port in the address parameter is empty or 0, a port number is automatically chosen. Some standard libraries invoke the listen function in this way. For example, we can use the HTTP test library to start our server for testing, but internally, the new server function called net.Listen function. Specifically, the new local listener, an unexported function in the HTTP test library, invokes net.Listen function with the port 0. It's an excellent and easy interface for us so that you can use this capability easily. However, what I want to describe in this talk is the specification and the internal implementation of the net package by reading Go code. Knowing the internal specification will help you make more profound design decisions. For example, what kind of infrastructure is suitable to deploy this HTTP server? What is the range of network ports that the server will bind? This talk will give you the basic knowledge to answer these questions. Let's have a look at the signature of net.Listen function. The first argument, network, specifies the network type. The network must be TCP, TCP4, TCP6, Unix, or Unix packet. Regarding TCP, what you should specify depends on whether the server instance supports IP version 4 or IP version 6. TCP4 means IPv version 4 only, and TCP6 means IP version 6 only. TCP indicates either IP version 4 or version 6. Then, let's move on the inside of net.Listen function. Here is a diagram visualizing the relevant parts. The two main libraries involves net and syscall. Subsequent slides will provide more detail. First, the listen function uses a net.Listen or listen config struct. A helpful tip for your daily Go life is that if you want to pass the context on the application code side, use listen config instead of listen. Then next, the listen function of listen config struct calls default resolver, which resolves the network IP address. Specifically, invokes the method resolve address list. It invokes many functions, but the following method is relevant for setting the port. It is lookup port. Lookup port looks up the port for the given network. For example, if you provide a port 0 to this method, it returns 0. It is an exported function of the net library, so that you can check the behavior directly. The main point is that it does not specify whose port a server will run on, but leave it at 0. Next, listen invokes a sysListener that contains listen's parameters and configuration. When the network protocol is TCP, it invokes the listen TCP function. Then next, listen TCP invokes net internal socket, which returns a network file descriptor ready for asynchronous I/O communication using the network poler. This function mainly handles low-layer handling, such as OS socket types and system calls and so on. This code gives sockstream as a socket type. OS layer technology, such as the Linux main page, defines several socket types. When you start an HTTP server, the network type is TCP, and Go program uses the socket type sockstream, a stream-oriented socket type. Otherwise, when you start a UDP server, it uses a socket type sockdgram. It is a datagram-oriented socket type. Like this, Go codes that perform network communications internally select the corresponding socket type. Then, the internal socket function invokes the function that bundles necessary system calls according to the socket type. For example, When the socket type is sockstream, it invokes the listen storing function, which handles listening to stream-oriented connections, such as TCP. It has been a long journey, but here we'll get to the heart to answer our original question. How does Go implement to bind an available port dynamically? The function executes three system calls in order: bind, listen, and get sock name. Bind assigns the socket address specified by the given address to the socket referred to by the file descriptor. Listen marks the socket referred to by the file descriptor as a passive socket. That is, the socket is ready to accept incoming requests using another system called accept. GetSockName returns the current socket address. We got to the answer. The rule over random port is the specification of the bind of each operating system. For example, if you start a server process on a Linux server, the system called bind will bind to an ephemeral port. An ephemeral port is also called a dynamic port. It is a port that is used for only a short period for the duration of a communication session. You can see the port range from the bind specification. For example, if you use Windows Server 2003, the port range is from 1025 to 5000. We will learn that when you want to launch a server on a random available port on any instance, you should check the three things. First, you'd better confirm the bind specification. Second, you'd better check if your infrastructure can use an ephemeral port. For example, suppose you use AWS Fargate, a fully managed container orchestration service, as an infrastructure. In that case, you can't bind an ephemeral port because automatic assign reserves them. Third, you'd better check the range of ephemeral ports. Considering a network firewall setting may be necessary if you use this capability on a remote server. You can see more detail in this article. Please check it out. That's it for me. Thank you for your watching.